So in this part, I will teach you about the remaining three states: suspend ready, wait block and suspend wait. And in the previous part, I taught you about these four states: new, ready, run, terminated. So now let's come to this wait block state. So what is wait block state? Wait block state means what? If a process is running and suddenly it needs I/O, input output device, it needs a value to be entered from the keyboard, suppose. So for that, it will have to wait for that value to be entered by the user. Okay. For example, here in the RAM, suppose P1, P2 and P3. Suppose P1 is in a running state and P1 suddenly needs I/O. Then what will happen? So P1 will request for I/O. Now P1 will request for I/O and P1 will move to the wait block state. Okay. So P1 will be here. Initially, suppose P1 was here. Now P1 will be here. Okay. So here P1 will be busy with the I/O. Here P1 will be busy with the I/O. Okay. And P1 was initially in a running state. Now the state of P1 is wait block state. Here P1 is busy with the I/O. And since P1 is busy with the I/O, it has to leave the CPU so that other process can utilize the CPU. So maybe now CPU is given to P2. So here what happens? The P1 made a transition from run to wait block state. The state of P1 is here wait block, and now P2 is in a running state. Okay. So here, so that's about wait block state. And after the completion of the I/O, suppose P2 wants to resume. Maybe P1 has got the value which is entered from the keyboard. Now P1 wants to continue. Then what will happen? Then P1 will move from wait block state to ready state after the completion of the I/O. P1 will move from wait block to ready state. Okay. So why P1 will not move from wait block to run state? Because in run state P2 is already there. That's why. So now P1 has made a transition from wait block state to ready state. Get अच्छा से बंद करो तो. Okay. So this about wait block state and about these transitions. So now I will tell you about suspend wait and suspend ready. So what is suspend ready state? Suspend ready state means what? The processes which are in the hard disk, suddenly one process which is present in the hard disk, it wants to get executed earlier because of its high priority. Maybe the priority of this of that process goes up, so it should be executed earlier, but that process is in the hard disk. So basically what will happen? That process will be moved to the main memory. That process will be moved to the RAM. That process will be moved to the ready state. Okay, in order to get executed. So for that, suppose if the ready queue is already filled up, there is no space is in the ready queue, or you can say that the RAM is already filled up. Then what will happen? Then one of the process from the RAM has to vacate, so that some free space will be created, and that process which we are in the hard disk will be can move and stay in the RAM. Let me draw an let me explain you with the help of figure. It's a hard disk. Here suppose there are two states, P1 and P2. Suppose there are two states. I'm just giving an example. And this is a hard disk and it's a RAM. Here P3, P4, P5 is there. Maybe P3 is in a running state. Maybe P4 is busy with IO, suppose maybe. And suppose the priority of P1 goes high. So for that P1 has to be executed. So for that P1 wants to enter into the ready state. P1 wants to enter into the RAM from here to here, from new state to ready state. So for that, suppose if the RAM is already full, there is no space left. So one process from the RAM has to vacate. It means what? One process in the RAM has to be suspended and moved back to the hard disk. So here one process is in a ready state, will be suspended and its state will become suspend ready. Maybe P5. P5 is in a ready state, so P5 will be suspended. P5 will be moved back to the hard disk. So now here empty space is created. Okay, so there is a transition from ready to suspend ready. It means what? Initially P5 was in a ready state, now P5 is suspended, and now there is a transition for P5 from ready state to suspend ready. So P5 is has moved from RAM to hard disk. Okay, why? In order to create a space for the upcoming process, so that P2 can easily reside in the RAM. Okay, so now P2 is in a ready state. So P2 has made a transition from new state to ready state. And how this transition got supported? Because P5 made a transition from ready state to suspend ready state. Okay, so this all about suspend ready. And suppose after some time again some space is created in the RAM. Okay, then P5 can again come and sit in the RAM. It means what? P5 can make a transition from suspend ready to ready state. Okay, so P5 can again come to the RAM. So that's why here there is a transition from suspend ready to ready. Okay, I think I'm able to make you understand this. Now let me come to this one, suspend weight. What is suspend weight? So suspend weight is similar to suspend ready. There is a small difference. Small difference is that let me give you an example. So, suppose the priority of P2 becomes high. Here P5 is in a ready state, P4 is in a running state, and P4 is in a wait block state, and P3 is in a running state. Let me write here. P3 is in a running state, P5 is in a ready state, and P4 is in a wait block state. Okay, and suppose suddenly priority of P2 becomes higher, then what will happen? So P2 will come to the RAM in order to get executed. So now, in order to create a space for P2, since a RAM is already full, So in order to create a space for P2, so rather than moving a process which is in the ready state to suspend ready, it means what? Rather than moving a process P5 from ready state to suspend ready, it's better to move a process which is in a which is in a block state to the hard disk. Why I am telling you? Here P4 is busy with IO. So definitely P4 will take some time to complete its IO activities. So that's why P4 is unnecessarily occupying the RAM, because here for some time P4 will not be given CPU. Okay, so it's better that so it's better to move P4 to the hard disk. So it's better to move P4 to the hard disk, and so that P2 can come here. So here what happened? P4 was in a wait block state. It was unnecessarily occupying the space of the RAM. Why? Because it was busy with IO activity. So it's better to move P4 from wait block state to suspend wait. Suspend wait means what? P4 has been moved from main memory to hard disk. It means what? P4 has been suspended. So P4 is now busy with IO activities, but it is in hard disk now. Okay. And after some time, when there is a space in a RAM, then suppose the space is created in a RAM, then P4 can again come here. It means what? When there is a space in a RAM, then P4, since P4 has made a transition from wait block state to suspend wait, so if there is a space in a RAM, then P4 will again come from suspend wait to wait block state. It means what? From hard disk to main memory again, so that P4 can again go to ready state. Okay, because the process can go to ready state. Okay, just leave it. Okay, or the P4 can make a transition to, suppose the IO of P4 is completed. So P4 can make a transition to suspend ready, and after that, if there is a space in the RAM, P4 can move to ready state. Okay. So this is all about process state diagram. So here some points are to be noted. What? Let me tell you. So here new state is related to hard disk. Okay. Ready state is related to main memory or RAM. Run state is related to main memory. Here CPU is assigned to the process. And terminated means what? The process has completed its task and PCB got removed. Wait block is related to main memory. Process will be busy with the IO, but process will be there in the main memory. And suspend wait is related to hard disk. Suspend ready is also related to hard disk. So I think now you are getting it, why suspend wait, suspend ready, both these states are related to hard disk. Okay. And the job, what is the task of long-term scheduler? It selects a process from new state to ready state. It moves a process from new state to ready state. Okay. And what's the task of short-term scheduler? It selects a process from a pool of processes in a ready state, so that that process can run. It moves a process from ready state to run state. Not exactly short-term scheduler. It selects which process will run, and after that it will direct the dispatcher to take the action accordingly. Okay. And also there is a medium-term scheduler. Medium-term scheduler. So you will get to know more about medium term scheduler when I will teach you memory management unit, page fault, all these things. So here I will give you a brief overview about medium term scheduler. What is that? It's a job of medium term scheduler to move a process from, suppose a process is unnecessarily occupying main memory space, okay, and some process wants from hard disk wants to enter into the main memory. So it's a job of medium term scheduler to select the process in the main memory which is unnecessarily occupying the main memory space and move it to the hard disk, so that the process from hard disk, so that another process from hard disk can come and enter into the RAM. Okay. So basically these parts deals with long-term scheduler deals with these parts. Okay, why? Because here a process is moving from main memory to hard disk. Why? So that another process from hard disk can come to the ready state. Here also the process is moving from main memory to hard disk. Why? Because another process from hard disk can come and enter into the main memory. So that's all about process state diagram.